Hello. Welcome to lesson number 2. I'm going to put a number 2 for organization purposes. Alright. Solving for x, one-step equations, when we have to add or subtract. So in the last lesson, you learned that x is one of our terms in math. So what is x? Well, when you were in elementary school, they probably taught you that the x meant to multiply. It'll never mean that again. Never again. Please don't write x as multiply. It will just confuse you. X does not mean multiply. It's usually a dot, or if you see a parentheses, it usually means to multiply as well. Alright, by middle school, x becomes a number we don't know. It means it could be any number in the entire world. It just represents a number. In high school, it starts to become, and you'll find this out in a few months, but in high school we'll start to think of it as representing time. Representing time. Alright, but today we're going to be using the middle school definition, which is just a number we don't know. So, when you look at this, it says something, some number, plus 3 is 5. Well, logically, I know that 2 plus 3 is 5. Since I know that, that means x must be 2, right? X is 2. However, we can't always use logic to solve in math, because sometimes it's a lot harder than just 2 plus 3. So how we do it is that, like last time, if there's a equal sign, you make a wall. And now right now the left is equal to the right. Whatever x is plus 3 has to equal 5. So our goal is to isolate x. Isolate means to be all alone. And right now on the left of this wall, x isn't alone. It has a plus 3 with it. Well, to move over a wall, to move over an equal sign, you have to do the opposite of what you see. So the opposite of addition is subtraction. So if I have 3 and I minus 3 away, then 3 minus 3 would become 0. And that would make x be all alone. However, if I just minus 3 on the left, they're not equal anymore. So to keep them equal, I also have to minus 3 on the right. So 5 minus 3 is 2. So now mathematically I have solved that x is 2. Next we have a subtraction example. So something minus 1 is 4. Logically, I know that 5 minus 1 is 4. So x is 5, right? Well, again, if it's not that easy, you have to do it mathematically, which means you need to draw that wall. And on the left side with x is a minus 1. So to undo subtraction, to make that become 0, I need to add 1 to it. But if I do it on the left, to keep my sides equal, I must also do it to the right. So on this side, x minus 1 plus 1 cancels, so I just have x equals 4 plus 1, which is 5. And I've mathematically solved that x is 5. Next, negative 2 plus some number becomes 8. Well, negative 2 plus 10 becomes 8. So x is 10. However, if you didn't know that logically, you can draw your wall and say that on the left side with x is a plus negative 2. And to undo something that's negative, I need to add it. Because negative 2 plus 2 becomes 0. But if I do it on the left, I also have to add the 2 to the right. So now, negative 2 plus 2 was 0, it canceled out. I'm just left with x equaling 8 plus 2, which is 10. Next, 9 plus something is 18. Well, 9 plus 9 is 18. Oops. It gets harder and harder to write the further down this page I go. So, x is 18. Oh, no, it's not. It's 9. X is 9. However, if I didn't know that mathematically, I can draw a line where the wall is at the equal sign and make my wall. On the left is 9 with x. It's a positive 9. So to get rid of a positive, I subtracted it away. And then I have to do it on the right-hand side too to keep it equal. Now 9 minus 9 is 0. So I'm just left with the x on the left equaling 18 minus 9, which is 9. So x is 9.